Hi guys, welcome to your next chemistry video. Today's subject, matter and its properties. So matter, as you all should know, is anything that has mass and volume. So, properties of that matter. First, we can look at extensive properties. Extensive properties depend on the amount of matter that is present. So if you change the amount, you change the property. So such things as mass, volume, shape. So it can depend on the amount of matter that is present. Intensive properties do not matter on the amount of matter that is present. So examples of these would be density, boiling point, and everybody's favorite, flammability. So as you guessed, we're going to look at states of matter. So the first state of matter is a solid. You can see that a solid has low energy. There is some vibration going on, so it's not like there's nothing happening. So even that chair you're sitting in right now is vibrating. Not enough to give you a good massage, but it is vibrating. So it has low energy, but it is a fixed volume, and it does not depend on the shape. It's a fixed shape, no matter what container you put it in. Liquid, on the other hand, you can see the energy is a little bit more. It has raised. Particles are moving a little bit faster. This time they will have a fixed volume, but it will take on the shape of its container. Gas has a much higher energy, so particles are moving around much faster, and they're going to take on the shape of their container, which means the volume is going to change depending on what's going on. And finally, we have plasma. Plasma is a high energy state of matter. So this is our highest energy. And you can find that in the sun and other stars, in lightning, fluorescent and sodium bulbs, and then the aurora borealis, if you've ever had a chance to actually see that. Maybe someday I will. So on to building blocks of matter. Atom. An atom is the smallest unit of an element. As long as we have the atom, we have all the properties we need of that element. If we go any smaller, then it no longer has the properties, and we're looking at the subatomic particles. But you can go larger, but you're going to be adding a bunch of atoms together. So an atom is the smallest unit of an element. An element is a pure substance made up of all of the same atoms. And finally, a compound. Compound is made up of atoms of two or more elements chemically bonded together. Changes in matter. First change is a physical change. Physical change does not involve a change in identity, such as chemical composition. It's not going to change how it is physically made. It may look different, but it does not change what it is made of. So let's have my daughter here show you a quick physical.
This is the physical change. You might see why. Jump! Jump! Look inside!
And there Sky shows you how just ripping up a piece of paper changes what the paper looks like, but it does not change the physical properties of that piece of paper. Next we have chemical changes. Chemical changes is when one or more substances changes or is converted into another substance. So whatever we start with is going to be our reactants. So that's what we start our reaction with. Then this is the actual reaction, and we get products. So products we end with. So this is the end, and this is the beginning. And here's Sky to show us how to do a chemical change.
This is the chemical changer. Can I do it? All of it? Stand up.
This is a chemical change. As you can see, there were bubbles, which is a big significance of a chemical change, the production of gas. There was a change in color a little bit, which is hard to see in the video. But that went through a chemical change. We have converted the two substances into one completely different substance. There's no way that we could get those substances back. So now let's look at classification of matter. So first classification of matter would be a mixture. So a mixture, we can tell, it can be separated. So our big thing, it's going to be easily separated. So mixtures are easily separated. We can distill them, we can filter them, we can use paper chromatography, we can even just use a magnet on them. How well they are separated, or how well they look separated, will also depend on its classification. So we can have mixtures that are homogeneous, meaning they are uniform in composition. They are often called solutions. And some examples would be air, stainless steel. You're not going to see the different parts in them. Other mixtures are heterogeneous mixtures. These are not uniform in composition. So you're going to be able to see the parts, such as granite and wood. You can see the ripples in them, or you can see the different pieces of rock and minerals that are in them. If you cannot separate them, they are considered to be pure substances. However, that does not mean pure substances can be separated, as you can see. However, for pure substances to be separated, it has to be done chemically, either through electrolysis or some other kind of chemical change. So pure substances, although they are considered pure, can still be compounds. As long as they can't be separated by any of the ways in the previous slide, then they are still considered pure. So water and sugar, pure substances, but they can be separated. If they cannot be separated, we call them elements. Elements, I guess, if you want, can be separated down into individual atoms, but they're all one single atom, or the same type of atom, I should say, throughout. So looking at the periodic table. In the periodic table, you will find groups, or often called families. These are your vertical columns. For example, this would be group 1. If it doesn't have a group name, it's got a family name. So like a carbon family, if we were looking at the carbon column. So these are our vertical columns, and they all have similar chemical properties. That's what's going to make them unique. So everything in this column has similar chemical properties. So next we have periods. Periods are the horizontal rows on the periodic table. In a horizontal row, the chemical properties change regularly. So they aren't all similar, and you're going to see things change, but how they change is in kind of a pattern, and it repeats as you go to a new period. So you can see going across, we took one of the periods and we go all the way across the periodic table. So periods are horizontal. The periodic table can also be separated into sections. So first we have the metals. Metals are good conductors of heat and electricity. They are malleable, so you can hammer them into thin sheets. They are ductile, so they can be pulled into thin wire. They have luster, so they are shiny. And they are located in this region here. So anything that's this yellowish color are our metals. You can see most of our elements that we have found have been considered metals. Next we have nonmetals. Nonmetals are poor conductors of heat and electricity. They are very brittle, and they are on the right side of the periodic table. So we have a small section of nonmetals. In your find most of your gases, and you can tell just by properties they are the opposite of metals. So because we have our metals and then we have the opposite in the nonmetals, we have to have that gray area. We can't just change right away from a metal into a nonmetal. So our gray area is basically the metalloids. And these are located between our metals and nonmetals, and usually we call it the stair-step region because you take a stair-step down. Some periodic tables even have a nice red line that shows the metalloids. So they are between our metals and nonmetals. So they are kind of the elements that lie along here, with these being your nonmetals and these being our metals. So because it's in between, it's going to show characteristics of both the metals and the nonmetals. And finally, we have the noble gases. They're kind of set to themselves because they are all generally unreactive. They don't do much of anything. Probably the last ones found, so last ones on the periodic table in their own group, so they're all similar in properties because they are going up and down. They're in a group, but they are generally unreactive, so they get their own characteristic name of the noble gases.